Let's start with the subject network analysis. So, as the name suggests, this subject deals with the analysis of a network. So, before we go to understand what are the different types of analysis performed on a network, we first need to understand what a network is. So, for this, let's dedicate this particular chapter, which is the basic terminologies, to understand what a network is and what are the different elements of a network and how is it useful for us to understand what a network and a circuit is. So before going into the terminologies, there is a basic difference between a circuit and a network. Some term the subject as a circuit analysis and some term this as network analysis. So what are these two terms? Are they essentially same or there is a difference between these two? Well, there is a minute difference between a circuit and a network. So the word circuit itself is not specific to electrical circuit. So for example, if there is a bike race or a car race which is happening, so in that case it travels through a path and come to the same point again. So such a path is already termed as a circuit. So wherever we are starting at the same point and ending at the same point, so such a track is known as a circuit. Essentially, an interconnection of electrical elements such as the resistors and the voltage sources, so these are something what we term as the electrical elements. So when we interconnect those elements and after the interconnection there exists a closed path for the charges to pass through, then such a interconnection is called circuit. On the other hand, when we talk about network, a network is also the interconnection of elements, which are the electrical elements. But the thing is, it may or may not have the closed path. So we deal with this term network multiple times. Let's say internet, or more commonly we talk about social networks. So what is a social network? A social network is a network which connects two elements. So in social, we term it as connecting two people through some media. So that is a social network. Similarly, whenever we interconnect the electrical elements, then that is termed as a network. So the basic difference between a circuit and a network is that circuit must have a closed path and a network may or may not have a closed path. So from this explanation, we could understand that all the circuits are networks, but not all the networks are circuits. Basically, whenever it is an interconnection of elements, it is a network. On top of it, when it has a closed path also, then we term it as a circuit. Okay. So why we are concerned about the circuit is a place where we can deal with the movement of charges, or in more important terms, we term it as a flow of current. So basically, a circuit is where we can understand the flow of electrons and we can deal with compute what is current flowing in a circuit, what is the voltage across it, and those analyses can be performed only with a circuit. The next terminology that we are going to understand is a node. A node is nothing but a point where two or more than two elements are connected. For instance, this is an element, this is an element, and this is also an element. So if you could see this green dot, this is a node. And this node is connecting three elements here. So whenever we have the interconnection of the elements, the interconnecting point is something that we term it as a node. So let's compute what is the number of elements connected to a node. Here it is 1, 2, 3. So technically, I basically term this the number of elements which are connected to a node as the degree of a node. And the symbol for this is delta. So if I tell the delta of this node is 3, then it means there are 3 elements connected to it. Okay. So whenever there is a 2 element connected to it, we essentially cannot have 1 element because it is basically the interconnecting point of 2 or more elements. So delta can never be 1. So if we have delta equal to 2, which is basically we are connecting 2 elements to a particular node, then this node is basically a simple node. On the other hand, if we connect more than two elements to a node, then that particular node is something that we term it as a principal node. Okay, so we can take this example as we could see here. So let's compute the number of nodes in this network. So this is a node which is connecting these two, and this is a node which is connecting these three elements together, and this is a node which is connecting these two elements. And now comes the other part. Here if we could see, this is a node which is connecting 1, 2 and 3. Essentially we cannot term this as a node because it is not connecting two elements. Basically we cannot term these two as a separate node because there is no element in between which is connecting these two nodes. So basically whenever we have different points connected through a single wire, then that is termed as a single node itself. So everything here is a single node. We consider as a single node. So basically in this circuit, if I could consider, this is one node, this is second node, this is third node, and this is my fourth node. So everything over here is a single node, right? So now if we could compute, it's the delta of an individual nodes. So this node, the delta is basically 2 because it is connected to 2 elements, and this node has delta as 3 because it is connected to 3 elements, and this node has delta equal to 2 because it is connected to 2 elements, and this node has delta 3 because it has 3 elements connected to it, right? Okay, so now let's come to the next terminology, which is branch. So branch is nothing but the element. To be very simple, a branch is an element. So basically if we could see, this is a node and this is a node, and this is an element which is connecting these two nodes. So basically the branch represents an element that connects two nodes together. Okay, so we can simply compute the branch by calculating or just computing the number of elements in a network or a circuit. For instance, here we have different branches. So this is our first branch, this is my second branch, third, fourth, fifth and sixth. So there are essentially 6 branches in my network or a circuit. Now when we talk about nodes, this is my first node, which is node 1. This is my second node, node 2, third node, and this is my fourth node. So there are essentially 4 nodes in my circuit. So if I could compute the delta of each node, for instance, let's say this is node A, the delta of A is basically 1, 2 and 3. Similarly, the delta of B is 1, 2 and 3. For C, essentially we also have 1, 2 and 3. And for D, also we have 1, 2 and 3. Okay, so this is the branches and the elements as well as the nodes in a particular circuit. Now if we could sum up all the deltas of a particular circuit, it comes up to be 12 in this case, right? So basically the summation of all the deltas in a circuit is 12. So as we could see, the number of branches is 6 and the sum of deltas of a circuit is 12. So basically we can term it as my sum of delta will always be 2 times the number of branches in a circuit. Here it is 12 and the number of branches is 6 and it is 2. So for this case this is fine, but how are we generalizing it? Always that my delta I will be equal to 2 times the number of branches. How can we generalize this? So this is from the fact that every branch contributes to 2 deltas, right? So if I have a branch B1, then it is going to contribute to 1 delta here and 1 delta here. And if I have a branch B3, then it is going to contribute to 1 delta here and 1 delta here. And similarly, if I have a branch B2, it is going to contribute for 1 delta here and 1 delta here. So essentially this node will have 2 delta, and this node will have delta as 2, and this node will have delta as 2. So every branch contributes to 2 deltas in a circuit. That's why the total degree of a circuit is given by 2 times the number of branches. So the next term that we are going to look is loop and mesh. So basically we have a closed path in a circuit, as we have already discussed. So any closed path in a circuit that starts and ends at the same point is termed as a loop. For example, in the circuit we have one loop, loop 2 and loop 3, right? So there are loop 1, loop 2 and loop 3. So any electron which is starting from here can have, or any charge which is starting from here can have different paths. It can travel through this, reach the same endpoint, and it can travel through this, reach the same start point, and it can also travel through this and reach the same start point. So basically this circuit has 3 loops in it. On the other hand, if we look at a mesh is also a loop, but this loop should not have any smaller internal loops. For example, this is a mesh, this is a mesh, but this is not a mesh, because within this we already have 2 loops or 2 mesh internal to it. So this basically are some of the unique loops in our design. So all the unique loops in our design, we term it as mesh. This will be helpful for analysis. We'll look into this in our forthcoming sessions. So from this, what I could tell is all the mesh are loops, but all the loops are not a mesh. So this is intuitive and understandable. So we also have a way to compute the number of mesh in a network. For instance, here we have 2 mesh. This is mesh 1 and this is mesh 2. So the number of meshes is basically 2, and the number of mesh in a given circuit can be computed by using b minus n plus 1, where b is the number of branches. For instance, here we have 1, 2, 3, 4 and 5 branches. So I'll have 5, and the number of loops, number of elements possible is basically sorry, n is the number of nodes. So the number of nodes possible here, 1, 2, 3 and 4. So there are 4 nodes in this design. So I would have branches as 5, and the number of nodes is 4 and plus 1. So basically I'm having just 2 meshes in my circuit. That's all. The last topic that we are going to look today is the planar and non-planar network. So basically any network that can be drawn in a 2D is termed as a planar network. If we cannot draw in a 2D, then it is termed as a non-planar network. The point is, whatever the analysis that we are going to look upon is only for the planar network, and the analysis and the technologies and the analysis that we are going to look upon is not applicable for the non-planar network. Essentially not all the theorems, everything that we are going to look upon is applicable for non-planar networks, and it is only applicable for planar networks. So now comes the question. So this looks like a 3D network, right? This looks like a pyramid. So is this a non-planar network? No, essentially this is a planar network. So if we could see, the same circuit can be redrawn as, so I would take the same circuit here. So if I could take this and this, and if you look from the top view, this O can be put here. So this O will lead to this, 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 each being A, B and C, right? So basically these 3 elements can be put like this and can be drawn in a 2D fashion. Similarly, if we take the second circuit that we have in our hand, So this circuit, let's try to understand what this particular circuit is. Here also this looks like a 3D circuit, but essentially this is not a 3D circuit. This also, if we look from the top angle, this is basically a redrawable circuit like this. So we can have something like this, right? And I can have something like this. Basically whatever the internal loop that I'm having here is basically this whole network. Okay, so from the top view, if I could redraw it, I could redraw it in this fashion. So you could take some time and understand how this could be redrawn into this. So essentially this is also a planar network. Okay, so the point is, just by looking at the circuit, we cannot term it as a planar and non-planar network. We should try to redraw it in such a fashion that whether this can be redrawn with a single plane or not. If it is redrawable with a single plane or a 2D plane, then it is basically a planar network. If not, it is a non-planar network. So one example we could see here. In this example, this also looks like a 3D because there is a jump that we are seeing here. So but this is also a planar network because when we just remove this, we can redraw this as this. So basically this is also a planar network. But here is a special case. So we are seeing two crossings here. One is this crossing and one is this crossing. So if I remove this particular guy, so from the network, and I can redraw it as like this, but I cannot remove this particular segment and redraw it, because whenever I attempt to redraw, I either has to cross this one or I have to cross this one to reach this portion. So basically this circuit cannot be redrawn in a 2D plane. So that's why this is a non-planar network or a non-planar circuit. So as a summary, we have discussed what is a circuit and what is a network. A circuit should have a closed path, whereas a network can or cannot have a closed path. Then we discuss what is a node, and we also discuss what is a degree of a node. And we discuss what is a branch, which is the number of elements in a particular circuit. And we also discussed the sum of the degrees of a node will be equal to 2 times the number of branches. This is from the fact that each branch is going to contribute to 2 deltas. And we discussed on loop and mesh. Loop is any closed path that we can have in a circuit. Mesh is also a closed path, but it should not have any internal loops in it. So to compute the number of mesh, it is b minus n plus 1, which is basically the number of branches given by b, number of nodes given by n, and it is b minus n plus 1. And we also discussed on the planar and non-planar network. So we should try to redraw a given circuit in terms of a 2D plane. If it is not drawable in that fashion, then it is a non-planar network or a non-planar circuit. So that brings us to the end of today's session on basic terminologies. In tomorrow's session, or in the next session, we'll discuss about some of the basic quantities used in a circuit analysis. Thank you.